Good evening, everybody. As per my publication, today's session I will focus on the practical aspect of current generators. Why did I say practical aspect of current generator? The answer for that is when we study these things in our school and college career, mostly we have studied the concept part. But whenever we go to the market, our surrounding, our society, and we find the application of that particular science is a big difference. I have experienced that, and that is why I have mentioned this is a practical approach. See, welcome friends, those who join. As I have already said, I repeat, we already have studied more or less the concepts of science and especially the concept of electricity generation, that means current generation, and specifically if we focus to the Faraday's laws of induction, I will concentrate on that particular because we know current is produced in different manners. But today's topic, I will focus Faraday's law of electromagnetic induction. And we know that after Michael Faraday's experiment, this was published in Science, and thereafter the technology people they started doing experimentation and then prototype model and then research and innovation continues till today and it will continue till future also. Mr. Sriram, I'm very happy that you have joined. So let us discuss. I have already made the device ready to show you the concept of dynamo as we have seen in our previous models of cycle. Those who are keen to learn, they observe many things in our surrounding. And during my school days, I have seen people fixing a dynamo on their wheels, especially the dynamo particular part will be contact with the tire, and I have procured one of that. And if you will be happy, you can see I show you this one. This one, particularly this wheel, gets in contact with the tire and this starts rotating. And when that starts rotating, this is the internal part which I have opened for all of you to see. This is a cylindrical magnet and fixed with a stud, and the stud fitted with this innovated product which gets in contact with the tire, and tire during movement this also moves, and when this moves the magnet moves inside which inside the coil setup. Coil setup, I have again made it ready here. You can see the internal design of the coil setup. Again, this is a cylindrical concept. And this magnet can go inside same with a hair gap. When engineering and technology of current generation is concerned, we use a term hair gap. What is that hair gap? I must demonstrate you. Actually, I have removed all the wires that was present here, and I have only applied say 50 meter of wire all along. And gradually I will show you. But I start with the demonstration first. Inside these slots present on this body of the dynamo, I will show you when I introduce the magnet, it goes like this. This is called 100% hair gap. Now you can see the deflection of the meter zero and two wires coming out from this body are in contact with these 2 points of the galvanometer. And then I rotate and you see the meter deflects. This is a proto model. Rather, this is for demonstration purpose. I have modified it. So when this is moving slowly, although current is flowing, that means electrons are flowing in the loop starting from the wire through the galvanometer and then coming back to the wire. So this fundamental experiment which we had studied in our school days, we never saw a setup like this in our classroom. We just saw a coil and a moving magnet to and fro. So that to and fro movement we had seen, but here all commercial generators they cannot have here and there movement. They have to confine themselves in a circular volume. So the design is like this, and now I open it and we will discuss more and more. Let that galvanometer duty is over because it also helped us to make understand that I am there to show you current is produced. And now I come to the body of the dynamo. See how is the body designed? This is well displayed before you. This is a PVC tube, and internally they have placed some GI sheets starting from the surface to these particular points 1 and 2, 1 and 2, 1 and 2, 1 and 2. So they have placed 4 sectors: sector 1, sector 2, sector 3, sector 4. And in all these sectors, they will wind copper wires as I have shown you here. These gaps, see the where I have placed by removing the original. I have just shown you a segment only, a little bit. But in the reality, when we make it again, I will make it again and I will rewind it with full new wires. And this gauge which I observed is little thin and I will give little thick wire. So suppose this wire is 32 SWG, I will provide, for example, 30 SWG or 28 SWG, and after providing conductors, that means the wires in all the slots, they will be connected. So these two terminals will be left behind. So my question is to all of you, who are these two terminals? These are the two terminals in your dynamo of the bicycle. You might have observed one goes to the body. The body is a metal that will be passing through again, and one terminal will be open from where there will be a conducting wire running through the body of the cycle to the lamp, and again the body of the lamp will be fitted to the body again. So body, that means in all commercial designs, the body itself is a conductor. That means one wire they carry up to the device or the gadget, and the body is the other conductor. So the cycle, because it is made of iron, and one part of the dynamo is already connected to the metallic portion of the cycle. So the whole body will be a conductor for the lamp. So this is the idea. And when I place the magnet, you again observe the gap in between. So there is almost no gap. Visible gap is not there. But after positioning, you will find this will rotate. And when this rotates, this induces induction takes place and EMF develops across these two terminals. That means in all commercial generators, it is basically the movement of the magnet taking place, and the coil is fixed, and across these two terminals they collect the current. I have seen the dynamo in motorbikes. It is different, but same is the design. That is, magnets must be moving and coils are fixed, and it is easy to collect the current from the coils. Now let us go to our school design. Whatever we have studied in college level or school level science, as far as current generation is concerned, I show you the idea is like this. This is the conductor part of the dynamo, or rather AC generator, because fundamentally the law of induction says the EMF produced and the current generated because of that will be alternating in nature. Alternating in nature, from your study in books, there will be a sine curve, and the reference line will be 0, x axis, and it will be going to plus 1, and then again 0, then minus 1, and then 0, and that is a cycle. We will show you again using oscilloscope in another round. So let us observe how is the armature made rather. Conductors are placed in lengthwise like this. I have prepared it. I have done it. The axis, that means a shaft running through. And thereafter, the ends of this conductor, I have connected two individual full rings. You can see soldering points. At this point, one wire is soldered with this ring, and another end goes through the wooden material without any direct contact between this ring. It goes through the wooden material placed below and then connected here by a soldering. So if you want to verify using a multimeter whether, if you connect these two terminals, that means the whole system will be a single conductor, and it will be shown by our multimeter. I will show you now. Let it be here before all of you. And what I'm doing next, I place multimeter here again for your observation. This multimeter, we have to keep it here in this ohm position. That means whenever we are measuring the continuity of a conductor, we must ensure that our meter reader must be in the ohm position. So it is now 0, and I will show you using the probes. Here one point and here another point. You see, because of the total length of the coil, it has got an inbuilt resistance, and this is coming 41.3 ohm. But if I do not contact my body, it will be little less, I think. It's okay, 41.5 or 3. It's okay, no problem. Now the same piece of conductor I have again connected to a half ring section here. That means one half of the ring is connected to one terminal and the other half is connected to the other terminal, and this is called commutator, and this is called slip rings. So the idea we studied like this. Now if I measure the continuity using the commutator also, you will find the same result, because the wear length should be same, but I do not know. Yes, somehow it is oxidized. If you rub it properly, it will be the same length. So no problem. We saw the design of the armature, and then I'm getting into the idea of a magnetic field. The magnetic field we have studied in our books like this. Over a piece of iron flat bent in this shape, one magnet will be here and the other magnet will be here. So if this is the North Pole, this will be the South Pole. And the lines of forces between the North Pole and the South Pole do pass here and there. And in this section, if it is placed like this on a board that I will do later on, your armature will be placed like this. So it is a big headache. It will be placed like this with strength. And thereafter, there will be an arrangement for rotation of this particular shaft. So when there will be a rotation mechanically by a gearbox or by a pulley block, whatever it may be the idea, current will be generated and will be collected by a pair of carbon brushes. Those will be in contact with this and this always. So this is the idea how current is generated using the conventional steady mechanism. In between a pair of magnets, your armature should rotate. And when rotates, you will be measuring the terminal potential. It will be alternating current that I will show you in the next episode when I make it totally furnished. Today I just got it dismantled everything to show you individual components. So this is one idea, and please wait for 1 minute. I will bring another material for demonstration. Observe the design of the armature. Now I'm back. So what I'm doing now, I remove it and I show you the commercial segment. This has been again, I tell you where from did we collect it. This is truly speaking the wiper motor. You know the wiper motor of the vehicles are like a cylindrical compartment inside which this moves. And when this moves because of motor action, this is threaded and this is connected to another worm gear and that moves the wiper blade on the windshield. So that portion we have removed from inside and we have shown you we have done it in a rewinding format. These are the segments all from soft iron and your copper wires are perfectly wound around and ultimately you know there will be two ends and finally the two ends of the conductor are connected to these four rings. So here is a slip ring and here is a ring. I can show you the soldering point. This is the soldering point. This is another soldering point. Internally it is done. See, one wire has gone through. This wire has gone through and soldered at this particular point here only. So this has done accordingly. And you know, if we again test for the continuity of this conductor, you will be watching again. I keep it here because these are the two terminals, and you see the total wire length, even though it is a little thick wire, that is why the resistance is too less. It's only 1.9 or 2 because it is thicker wire. But in the previous case, it was thin wire. And you know from your science, thin wire offers high resistance and thick wire less resistance. So after getting to that idea, we will discuss again another concept. This is a commercial generator. This I will show it today after recording. The demonstration will be on a short video. This is connected to 12-volt LED and this is a wind blown generator. Because you know, you just observe there is a arrow mark here. So the wind will be blown here and will be coming out this way. So they have made the threads accordingly so that you can post it permanently. Or otherwise somebody may ask if there is a flow of water also that can be produced. So it can be fitted in your bathroom on that connection pipe. So when water flows through this way and comes out this way, you use that water no problem, but this will generate current. And for today's purpose, I will keep it here as such and I will show it in my short video in the evening and I think uploaded by 10 o'clock. So this was the idea how we understand the concepts. But I will tell you one thing, if you have interest in assembling such items in your home, start the activities right now, and you will find while doing a lot of hurdles are coming, because then we need to have a mini workshop. That means certain tools must be with us for a finishing product. Some materials must be there with you, and proper devices must be ready for work. So, this being a company product, it is easy for procurement and for modification. But in company product, this was not there. Remember, this was not there. We modified this. But so, what about the company product? If you know, then you may comment upon. This was a segmented commutator. It was a 12 segment commutator. If you have seen a commutator, otherwise, I will show you next. 12 segment, 24 segment, 32 segment. Oh, even 8 segment commutators are available in the market, commercial commutators, and those are used in all commercial motors. So we have removed that and we have introduced a wooden piece here, and upon that wooden piece acting as an insulator, we have provided brass rings converting to two full rings. So like that. Rewinding to be done. So we have to have enamel copper wares, and the copper wire kg is almost 1600 rupees. So you have to procure all those things. There's so many works. So I am doing in my home alone, and I am uploading for people to view it. But the view percentage by the students is very less. It is only 0.7% up to the age of 17. And thereafter the view is little more. And video nobody is watching. So I am compelled to upload in the format of shorts. And shorts very difficult to understand. So live program is best for understanding. So I will continue the live program for dear viewers. It is very useful for all of us to get through the idea, and our subject knowledge and our practical approach will be enriched. And I hope we have time ready for all of us to wind up. And I must show you one important thing which I today observed. When I was observing this cylindrical magnet, I was worried about the polarity of the magnet. And when I was going to test, I will show you also here the test. I have a piece of magnet here, and this face suppose is North Pole. I show you using this, you have to observe carefully at what point there is repulsion and what point there is attraction. That means a fusion of North Pole and South Pole you can find on this cylinder. See, this point is getting attracted. If you remove to this particular point, again it is getting out, repulsion. So if this is suppose North Pole, this will be again South Pole. Again, if this is South Pole, then repulsion, then this is again attracting. So polarity is continuously changing. That means on this particular cylindrical segment, they have fused. That means the material has been so magnetized that it has got four segments: North Pole, South Pole, North Pole, South Pole, North Pole, South Pole. So continuously there are four segments of North Pole and South Pole in lengthwise, and that rotates inside the coil segment in the body. So this sort of magnets you don't get in the market. So commercial generators, whatever they make, their magnets are specialized. And please remember, if you collect it, you will understand best by yourself, as I understand here by myself. So this is all about repulsion. I will show you how repulsion is taking place. Attraction and repulsion, again attraction. repulsion taking place, no touch, it opposes attraction, again repulsion, attraction. So that I have experienced, and you will experience when you do by yourself at home. So I hope you have enjoyed, all of you. If you like, you be ready to attend everyday session I am planning to have on different topics. So please be ready, and we meet next. Thank you all.